So I'm going to be talking today about building a code editor in your browser. My name is Jo Franchetti, and I am a developer advocate at Deno. We're going to talk about building a browser code editor. But why might we want to do this? Why might we want to build a code editor in the browser? Aside from it being just a cool project, there are quite a few reasons why you might want to make a code editor in your browser. If you work at a company that has APIs or offers other tools to developers, it's a great way to really improve your onboarding experience. If you offer in-page code snippets that developers can actually test out and use your product immediately without needing to set up their own local environment or swap tabs or things like that. An embedded editor within your documentation will allow readers to try out your code immediately. And an in-browser editor can really just offer a sort of hands-on experience for your readers. So they'll be able to modify code samples, see immediate results, and gain practical experience of your code. And if you're running a low-code or a no-code solution, like we saw Toddle yesterday, you may find that occasionally your users require just a little bit of extra functionality or versatility on top of the product that maybe your product doesn't offer them. So allowing them a safe way to run their own code just gives them extra freedom to build on top of what you're offering without them having to find a new tool or a new product, for example. But running code written by other people presents us with a problem. We can't trust code written by just anybody to execute on our websites. Allowing third-party code execution can introduce security vulnerabilities. We might potentially be allowing people to run malicious scripts, to steal data, to inject harmful code, and it's just going to compromise our users' security and privacy. So we need to prevent malicious code from wreaking havoc on our own databases. Not only that, but we need to, if we're going to be running third-party code, we're going to need to provision resources to run this code, which is going to need CPU, it's going to need memory, and that could potentially impact the load pages of our own website, our own products. So in order to build a system that's going to run third-party code, we'd likely end up needing to provision a huge amount of compute. We'd need to install something like Kubernetes on it. Then we'd need some management APIs to make sure that only the correct shape of code is allowed to run and it is allowed to be deployed on our cluster. Then we need to make sure that the container instances are secure. We'll need to make sure that we don't run out of storage. And we're going to end up needing to employ an entire ops team, really. And the truth is, building your own managed runtime is a couple of $1 million worth of problem, which is, quite a significant barrier to entry for most people, just to make a cool interactive experience on the web. So with all of this in mind, how are we going to build an in-browser code editor, and what do we need to do so? So in order to make a sandbox that is going to run server-side code, we're going to need a few things. So first of all, we're going to need the end-user app. So imagine something like CodePen or JSBin or many of the other in-browser editors that you've used before. And then we're going to need something to host our app on so that users can actually go to a website and use it. And finally, we're going to need some sort of application platform to run that third-party code on. So something like a serverless functions runtime. And I work for Deno, and we have some products that try and solve these hard engineering problems for you and help you building these kinds of applications. But what is Deno? So we had a brief introduction from Luca earlier. Deno is the open source JavaScript runtime for the modern web. It's built with web standards, built with Rust in Tokyo, and V8. And Deno natively, as you saw, supports TypeScript out of the box, so you can write your strongly typed code, and you can catch errors early without having to do any complicated tsconfig setup. Deno also has a whole load of tools included for formatting, for testing, for linting, and it just really streamlines your developer workflow. And you might have heard of Deno. We've been around for a few years. Deno was written by the same author who originally wrote Node, but he wrote it after looking back at a decade worth of Node real-world experience. And his aim was to level up the JavaScript ecosystem. So he's trying to sort of narrow the gap between the browser and the server side by allowing TypeScript to be a first-class citizen. We also play really nicely with your modern web dev tools. So we're going to be building our solution out using Deno as the runtime. We're going to use Vite as our web dev server. And we're going to, of course, use React as our UI framework. And you might be thinking, like, OK, fine, you work at Deno, but why would I want to add Deno into the mix here? And the answer is this. Not only is Deno great for running TypeScript code and running it fast, but it's complemented by a whole load of other tooling that I will talk about. And it gives you development extra utilities to make running the whole thing through Deno not only easy, but also hopefully a delightful developer experience. So I mentioned that we have a bunch of other tools. The easiest and fastest way to deploy Deno apps to the cloud is to do so with Deno deploy. You might not know, but we're not only a runtime, we also build some really awesome tools for the web. So Deno deploy is a web hosting solution. It's kind of similar to Heroku, very similar to things that you will have used before. And it's a worldwide platform that provides great JavaScript and TypeScript hosting. Instead of running on virtual machines, the applications are powered by the Deno runtime, and they run on efficient V8 engines, which makes the deployment process super fast and super lightweight. And finally, for our serverless functions, we are going to use this thing called Deno subhosting. And subhosting is a set of capabilities that's built on top of Deno deploy, and is designed specifically for securely running code written by multiple different users in a hosted and secure sandbox. It supports JavaScript and TypeScript. It's optimized for fast deployment. And we're talking cold start times in milliseconds here. I'm going to avoid doing a massive sales pitch, but the cool thing about subhosting is that it's built for people like you. So it's built for the tool builders, the site builders who want to offer serverless functions to your own customers. But you don't want to have to worry about the infrastructure, the scalability, the DevOps yourselves. So let's build our app. The first thing we're going to do is we're going to set up Deno. If you've ever used Deno before, I'm sure you've done this before, you can install it using curl. If you're on Windows, you can use Chocolatey. And if you have used it before, Deno's constantly changing and updating. It's probably more familiar these days than if you tried it a few years ago. So we're going to set up a basic Deno project, and that is no more work than just typing Deno init. And much like creating a node package with npm init, Deno is going to create a Deno JSON file, which is going to have our dependencies, our metadata, and importantly, some tasks, which are Deno's version of npm scripts. So you can see our task here. Deno, we really care about testing. So you'll notice that Deno has also generated an example unit test there as well. Deno has a built-in testing framework to make your testing easy and fast and delightful again. So that's the 60-second intro to Deno. Now we're going to configure our repository to use Vite and do some actual web dev. So like I said, we're going to use Vite, we're going to use React, so we're going to install those dependencies, and we do that with the Deno add command, and then we're going to also edit our Deno JSON file and add a task called Vite start. So if you have a look here, you can see that Vite start task is doing Deno run -a, which is just going to give us all the permissions that we need. And then we're adding an extra compatibility flag in here, which is our node modules dir, which is just going to make sure that the node modules directory is present for any child dependencies that require it. When our next major release is launched, this will actually no longer be required. You won't have to do this anymore. And to set up the architecture for our app, we're going to make a client directory. You can see that on the left here, and a server directory. So in the client directory, that's where our Vite app is going to live. In the server directory, that's where our server-side APIs are going to live. That's where our Deno server-side code is going to go. So let's set up Vite config and configure Vite. So we need to make sure that Vite is looking at our client directory, so that's what we're doing here, and we're including React, React DOM, and we're correctly configuring our JSX runtime. Now, when we run that Deno's task, our Vite start, Vite is going to get executed by Deno and is going to be ready to host the React app that we're going to build. For the sake of brevity, I'm not going to tell you how to create a basic React app. I'm fairly certain everyone in this room already knows how to do that. There's nothing unusual about it. You just need to put an index.html and an index.tsx file in the root that uses React to get started. But let's have a look at some of the components that we're actually going to build out. So this is what we're going to build. It's a very basic editor. I only have 45 minutes here. If you're going to build this kind of thing yourself, then you can start to look at fun things like syntax highlighting and all of that. But for now, we're just going to put a text area in where the users can type in their code. We're going to put a button in so that users can execute their code. And then what we've got at the bottom is an iframe, which is going to display the output of the code that is being run. And then we're going to need some API functionality to create new code sandboxes every time the user clicks that Run My Code button. And our API code that we're going to write is going to call the Deno subhosting APIs in order to create new instances. So our users can see the effect of their code every time they make a change and they click Run. So let's have a look at building out that app. I hope you can all see that. So we're going to use React Router. We're going to create a single-page app. And this is our edit code component, which is going to present the text area. So hopefully you can see that down at the bottom here. We've got our text area, we've got our button, and then we've got a component called deployment viewer there, which is just the thing that's going to contain our iframe. So when the user clicks on the Run button, it's going to deploy their changes. We'll call the backend API that we're going to write, and it's going to return us a URL that's going to be displayed in that iframe component. Each subhosted function that we create, so each time the user edits their code, it's going to get its own distinct URL. So we're going to be able to change what is displayed in that iframe every time they click on that Run button. The only other thing of particular interest in our React app is this API client, which is responsible for doing all of our fetch requests. So there's a few functions in here. So the first one that we're going to look at, so this one loads our sample code. Then we have another function which is going to deploy our project, and it is responsible for both creating and updating the code sandbox. And then finally, we have this, which is going to wait for the deployment. So this is going to poll to see if our running function is ready. And we do this by getting the deployment API, by calling this getDeployment API here. But we've not built any of these APIs yet, so let's do that next. So when we deploy this application, we're going to need something to host it. At the moment, we've got Vite that is doing our hosting locally, but we need to make sure that Vite and our backend APIs play nicely together. So we're going to add a couple more tasks into our Deno JSON that when we're doing our CI, will build the static assets required for our React app. So we're going to create a Deno server-side app that we can actually deploy to host our React app. So we have also a main TS file in our server folder, and we're going to add a task to startup that is going to start that up with our. We're going to add a task into our Deno JSON that is going to start that main TS file. And then when we deploy, we're going to use our Deno server-side app to host the backend API that is going to be called by our React app. And our main TS file is going to look like this. So this is the entry point for our server-side backend API. This file uses a web framework called Oak, and you'll see here that we're importing Oak using the JSR package. So in this file, we're initializing Oak, and we're asking it to route the static files from client dist, which is going to be inside of Deno's current working directory. Yeah, so you can see that here. And when we run this app, after we've compiled our React app, it's going to act as a web server and serve the React app. We've already set up our Vite config, which is going to proxy the requests from /API back to this server. And all of this configuration means that we can use Vite as our dev server locally, and any requests to /API will get directed to the routes that we make available in our Deno app. But in production, our Deno app is actually hosting our static assets and our APIs all together. So the server-side API has a bunch of functions that we're going to use to implement the features that we mentioned earlier. So we are going to get sample code, deploy project, and get deployment. You'll notice that each route is mapped using its verb, and it's got its own path, followed by a function which is going to handle those matching requests. And finally, you can see we've got a route static files from helper that is going to make our React assets get served correctly in production. So let's build out each of these functions now. A nice first example of how to use Oak is to build our get sample code. So all this handler does is it's going to load a file from the file system using Deno's file system APIs, and it's going to return the body as a JSON object. And here you can see how Oak works. You need to assign the response body on the context object provided as a function. So let's have a look at something more interesting now. Let's talk about what deploy project does. And this is what is going to do most of the work for creating our subhosting instances. So when this API is called, the first thing we're going to do is check if an ID has been passed as a parameter. If we find one, we're going to presume that we are updating a project that has already been created. So our user has already typed some code in. They've already created a project with an ID, and now they're updating it. If we don't get an ID, we are going to use the Deno API to create a new project for us. And once we've got a valid project ID, regardless of it being new or already existing, we're going to work out what content we need to update the project with. So if our API has received some code in the body, we will use that and presume that that is the code that they have typed into our editor. Otherwise, we're going to default to some sample code. So if they haven't typed anything in, we're just going to give them a little bit of sample code which is going to help them create a project from scratch. Once we've got our project ID and our code, we're going to create a new files map which can contain as many files as we like. But in this example, we're just going to use the one file, which is our entry point, which is our main TS. And then we ask our client to deploy our project, passing it that file map. And finally, we return the project, the deployment, and the subsequent deployed URL data back to our web UI to actually update and load the iframe. And in order to keep our HTTP API handlers pretty simple, I've created this Deno subhosting client file. This is just an abridged screenshot of what this does, but what I want to show you here is that all this file is really doing is sending requests to Deno's subhosting APIs using fetch, which of course is built into Deno. And each of the functions on the subhosting client represents a Deno API call. So all we're doing here is we're validating the status codes, we're adding some nice TypeScript definitions to the subsequent response objects as we return them. So let's talk a little bit about subhosting and what it actually does. So subhosting is just a collection of APIs that allows you to create projects. Projects will be owned by your organization. So if you set up an account, you will have an organization. Your organization can create projects. Your authentication credentials allow you to create as many projects as you like. So if you are offering serverless functions to your customers, you might want to do so on a project-by-project basis. Projects are kind of like an organizational unit within deploy, and deployments share nothing between each other, even when they belong to the same project. And you can see so this is a screenshot of the API documentation. You can see some examples of what you can do with each endpoint here. So we've got list deployments, create deployments, get organization details, that kind of thing. So if you have multiple tenants or customers or users in your code sandboxing system, you'll be able to capture billing information per project because the analytics are reported at a project level. So you'll be able to bill each customer individually. And for the sake of this demo, each user's sandbox is going to be a separate project with each edit resulting in a new deployment, and each deployment has its own URL. In a real-world scenario, if you were building this, you would want to add in some functionality which was going to delete all the deployments as users make changes. But what you're going to really be doing here is a project per user kind of organizational pattern. And for those of you who are interested in the implementation details of subhosting, subhosting is quite an interesting and innovative approach to this idea of shared compute. Deno deployments are deployed into separate V8 isolates, and each one gets its own distinct sandbox instance of the V8 engine to run in. Each isolate has access to a virtualized file system and a fully sandboxed runtime, and each isolate has a separate state, and objects from one isolate can't be passed to another. So this is how we're doing that security. This is how we're keeping each user's details private. And on top of that, Deno subhosting uses two VPCs, one for routing incoming requests and another for isolates to access the internet. And this is how we ensure security of network traffic. So we've built our project. The next thing that we need to do is deploy it to somewhere so that our users can test it out. And Deno Deploy is an online tool which is very similar to any other GitOps CI-based tools that you've likely used before. You register your Git repo, and then you will choose which project you want to deploy, you can fill in a couple of options for how you want to build the thing, what you want to call it. The important thing is to make sure that we put our Deno task build task into, it's already gone, into the form option for the build task. And we deploy it, and it goes live. Awesome. So, fingers crossed. Everybody pray to the demo gods. Here's one I built earlier. Let's see if we can get our demo up and live. Here we go. Stunning UI work, I just want to say. So here is our demo sandbox. So what I've done here, as I mentioned, if the user hasn't entered any code, we will give them this just little demo bit of code. If I click on Create Interactive Sandbox, we set them up with a text area where they can type in, and it's actually run the code for us. So I can now type in hello future frontend, and if we run it, Hooray. Okay, so we can see we are running the code live. You can see the URL that is being returned. So this here is just an iframe with its own URL. But we can actually do some more interesting things here. So let me, where is my cursor? Did I lose my slides completely? Oh, no, they're in that other tab, I see. Live demos, never the best idea. Okay, so yeah, so you can see what we're doing here is we're running our existing code using this thing called Deno serve, which is a nice lightweight HTTP server. And it all just sort of works out the box. But the cool thing about sub-hosting is that we can actually install packages. We have a package restore that just magically works when you're using JSR and Deno. So let's try a slightly more complicated HTTP server. So this time we're going to use Oak, and we're going to do some routing. And I'm not going to type this, I'm going to copy-paste it, because I do not trust myself to get this correct. So what we've got here, we are importing Oak, and we're importing Oak's router. We are just going to send this little object here at the home route, but we could change this, we could add more routes in here. So now if we run this and we cross our fingers again, hooray! So we got our foo bar returned. And that's super cool. Like, we didn't have to install anything. That import was just done for us. It just works. As I said, you could potentially create other routes. I haven't set up this demo to be able to visit other routes. But if we open that URL and went to those other routes in the browser, we'd be able to see the output at that URL. And it's super cool. Let's jump back into my slides very briefly. So all of this code, this is all open source. I would love for you to take this and run with it to build your own cool things. It was an absolutely whirlwind introduction, I know, to Deno, to deploy, and to subhosting. If you do build something with this, I would love to see it. So you can get me on any of the socials at This Is Joe Frank. That QR code is a link to the slides, which also has all of my speaker notes in it, which has all of the links as well. So yeah, do take this, do make something cool with it. Thank you so much for listening. And we have some Deno and JSR stickers up here at the front. So do come grab a sticker when we are done. But yeah, thank you so much for listening.